To find the formula, we start with the difference quotient from earlier. We let h approach 0, which is done by using something known as limit. So, the instantaneous rate of change or the slope of the tangent of a function is the limit of f of x plus h minus f of x over h as h approaches 0. When this formula is applied, what we will get is a general expression for the slope of the curve of the function, the derivative. Let's try to use the formula on this function. F of x equals 3x plus 1. First, let's work out what f of x plus h is. We substitute x plus h into the function and we will get 3 times x plus h plus 1. This is just equal to 3x plus 3h plus 1. Now let's find the derivative of the function f of x. Substituting what we just found into the formula, we will get the limit of 3x plus 3h plus 1 minus 3x plus 1 over h as h approaches 0. By expanding the numerator, we find that 3x and negative 3x cancel each other out. 1 and negative 1 also cancels each other. As such, we are left with 3h over h. We can cancel out h because it is a common factor of the numerator and denominator. Remember that the limit of a constant is just the constant, so this is equal to 3. So we have calculated the derivative of the function f of x. Note that the derivative of a function can be denoted in several ways. Using Leibniz notation, it is dy over dx. Another notation known as the prime notation, also known as Lagrange notation, is written as f prime of x. As there is no right or wrong, it is up to you to decide which derivative notation you prefer to use. Now let's interpret what we have calculated. If the derivative of f of x is 3, this means that the slope of the tangent of the graph is always 3 regardless of the value of x. We know this is true because there is no x variable in the derivative. If we take a look at the graph of the function, we can see that this is right. The slope of the graph is a constant value of 3 over the entire domain. Now let's do another example. Let's find the derivative of the function f of x equals x squared. Once again, let's find what f of x plus h is first. Expanding x plus h squared, we will get x squared plus 2xh plus h squared. Now let's find the derivative again. Substituting what we know into the formula, we will get this. We can cancel out x squared and negative x squared, leaving us with 2xh plus h squared. From the numerator, common term h can be factored out. Then the h from the numerator and denominator cancel each other out. Finally, we evaluate the solution to the limit as 2x. Let's interpret the derivative of this function. The derivative of the function x squared is 2x. The slope of the graph at any point x can be evaluated by evaluating 2x. Remember that the derivative is the slope of the tangent at any one point on the graph, which is also the instantaneous rate of change at that point.
Created using Powtoon.